So when looking at your assignment on page 286, the first one I'd like to take a look at is H3O+, plus, which is C. Okay, so then we would show our H, 3 H's, and we show our oxygen. Now, and this one's a little different than the other ones because it has a plus. What does that tell you about one of those atoms? Yep.
It has one less electron than
Yep.
neutral oxygen.
Yep, so the total is going to be one less. So when we add them up, we get 9 electrons. But this plus says that there was an electron taken away at some point in time. So I'm just going to go ahead and subtract an electron from that. And then it'll be 8 electrons because that's what the plus stands for. Okay? So as we go down through the steps, I know there was one individual gone. So step 1 and step 2 I've done. Draw out the dot symbols. Count up the total number of electrons. And then I've got what I want to have in which to do 3. Number 3 says you have to place the 1 in the center that requires the most electrons to get an octet, or 8. Hydrogens will never have 8, they only have 2, so they're always branched. So oxygen would be in the middle, surrounded by your hydrogens. So there we go. So then what you would do, step 4 would be to show your pairs of electrons. There's step 4. Subtract out, once you've done all your single bonds, you're left with maybe some electrons, maybe not, depending upon how it works out. Then those extra 2 can't go around the branch, they go around the center. So here's some things to look at. Everything has to have 8, or hydrogen case 2. And your electrons before and after have to equal. So we've got rid of those 2 electrons, so now we have 8. And that would be, this is called a hydronium ion. And this is what forms in water when you add an acid to water. So when you add an acid to water, the water molecule actually picks up extra hydrogens, and they're called hydronium ions. And so when you test for pH or something acidic or basic, the more of these that you have, the lower the pH is, the more acidic it is. So we'll get into acids and bases and kind of work with that at the end of the year. So oxygen would look, or that molecule would look like this with lines. Okay? Any questions with that? So that's what the structure would look like. Any questions you guys have? So when I wanted you to do the line structures, you're going to have to do both. It's just manipulating the pairs to lines as covalent bonds. Okay? I'm going to do a second one that seemed to be a struggle for students, and that would be E. Okay? So I'll do E of the ones that I went around and double checked. We'll do that one. Okay. So E, when we draw them out, we've got a carbon, 2 fluorines, and 2 chlorines. This is called fluoro, difluoro, dichloro, methane. And it's used as a propellant for like aerosol cans. Used to be. They don't use it anymore because when they manufactured this and used that, they didn't realize is it messes with ozone, and it takes ozone and decomposes ozone. And so the thought is if you produce too many of these and it gets in your upper atmosphere, then it takes away the ozone. Okay? So that's why they don't use this much anymore, but this is called difluoro, dichloro, methane is what it's called. If you had to use the organic type of naming, that's what it would be. We don't really do that in here at any point in time. We do it in AP Chem a little bit, but even in there we don't do it a lot. So we add them up and we get 32 electrons. Now, I noticed a couple of you're not including all your electrons in your dot notation. It should, if you have 32, you should have 16 pairs you can count up. So if you're not showing all of them, then it's a wrong structure. Okay? So the one that goes in the middle is carbon, surrounded by fluorines and chlorines. Then, step 4, we put our pairs and share them. Okay, and that takes away 8 electrons. We're left with 24. Okay, then what we're going to do is surround all the outside. Step 5 is to say, hey, you surround all the outside, and if there's any left over, then you can place them off the middle. But the outside gets them first before the middle. That's the order. Okay. Now that really looks messy. If somebody looked at that, they would have doesn't really know much about how these work. It'd be kind of hard for them to kind of see how things are going on. So that's why you do the line structure and you clean it up. And this is what they'll have in biology textbooks for dichlorofluoroethane. Any questions you have with that? Does that make sense? So I'm using all of them. Everything has 8. I count them all up. There's 32 before, 32 afterwards. We don't show any of these with just single dots ever. They're always paired up when we do any of these. That's the way it's going to be. Yes?
For the line one, how do you know when to put like the dots with it? Because on the last one, it's like the dots with it.
Right. So the difference is when we get into, like tomorrow, deciding the shape of it, then it's important for you to show the electron pair off the center. Okay? Because that allows you to use kind of a chart to begin with to kind of understand what the shape is. If I have the pair there, like tomorrow, if I show the pair there, that's a trigonal pyramidal molecule. If I don't show the pair there, then it's a trigonal planar. So you'll know about that tomorrow. But if I don't show it, then you're going to mess up the shapes later on. See, on this one, the center one's not going to have any unshared pairs, so I don't have to do it. So good question. Yeah. Okay. So we get into talking about these things called multiple bonds. Okay. And I think it's helpful to show you something before we get into multiple bonds, so that when we start doing multiple bonds, you'll kind of see how certain elements can form 2 or 3 multiple bonds, and when some can't. So that's what I'm going to go ahead and do. Is I'm going to now you can copy this down at the end. I'll show it at the end, or you can copy it down now. It really doesn't matter one way or the other how you want to do it. It could help some of you. So this is the non-metal section, periodic table, and let's just take a look. I'm just going to put a symbol like of a X for all of these, and then show you their individual dot notation. So, let's just take a look at these individual atoms here. Can group 18 form any bonds? No. So that column is kind of like, we're leaving that one out. It's not going to form any bonds. So my question for you is group 17. How many bonds can group 17 form? One. Right? It can form it right here, at that location. Okay? So that's where it can form that extra bond. How about group 16? Can it form? Two. So this one can form a bond right here. This one can form two bonds here and here. Group 15 can share how many? 3. Here, here. And group 14 can share 4. Okay, so this is important for you to kind of know which ones can share multiple places. All right. So, let's take a look. This here, how many lines, once we form our bond, how many lines can go from chlorine, fluorine, bromine, iodine? How many lines can we have? So when we draw a structure, and we'll take a look back at this, okay, and this will help you. How many lines to the, and that's group 17, right? This is group 17, chlorines and fluorines. How many lines does it? It can only have one. Does that make sense? It can only have one. So, it can't have any more than one. If you're doing more than one, that's wrong. Okay? Hydrogen, how many lines can it have? One. Okay? So they can have one as well. So this one can only show one line. How about group 16? How many lines can it show? 2. Now, the problem with chemistry, guys, is that I try to isolate you guys where the rules always work, but they don't always work. Okay, it's like I before E except after. Well, maybe that one works all the time, but it doesn't work all the time. I don't know. Not an English major, so. But these rules aren't like 100%. You're like, Mr. Garland, you said that oxygen will always have just 2 to it. And I said, yeah, but there are exceptions. Okay? And so for the most part, that's a good thing to look at. All right? It can also have 2 single bonds, right? So it can have a double bond, that represents a double bond, or it can have 2 single bonds. All right? Group 15, we just keep adding on now. So group 15, what kind of bond can it have? You can have how many lines? 3. So those 3 could be like this, and this would represent what kind of bond? Triple. All right? 3 shared pairs. It could have, what else could it have?
A double and a single.
Double and a single. Okay? Or it could have all 3 singles, right? Does that make sense? Group 14 will have possibilities of a triple and a single. You could have 2 doubles, or you could have all. You have all of them. So if you have that just to kind of look at and work off of, maybe things will get a little bit easier. Now let me show you an exception, because it's like, you know, like I gave you a problem and there's an exception to it. This is an exception. All right? This is a hydronium ion. So a lot of times your ions that are polyatomic will be exceptions. because they've lost or gained electrons, okay? So if they've lost or gained electrons, then that can be an exception. So just remember that when, and it's hard to remember, I know. If you got something that's positive or negative, it's probably not going to follow this guideline. Okay? They're polyatomic ions, probably not going to follow that guideline. Okay, so now that you got a little information, let's do an example where when we get down to step 5, it's not going to work. So here it is. Here's one that I'm going to have you do. SiH2Se. So what you'll do is go step 1 through step 5. You'll stop. And then you go, wait a second, this is not going to follow the octet rule. What do I do now? So if you want to go ahead, you can look at step 6 to see what you need to do. I think most of you are pretty quick. You got down, you count them, you put them on there, and you got 4, 5, 6. You got 12 electrons you've got to deal with, right? In total. So then you put Si in the center, and you surround with H, H, and Se. Then the next step says for you to just go ahead and put your pairs. Step 4. Okay, and then subtract them out. So we've got 6 electrons left over. Then where do those electrons need to go first? Around the branched atoms, and it would be Se. So you put them around Se. This is step 5. We're out. We're done. So you guys realize there's a problem with this structure, right? What's wrong with it? There's only 6 around Si, and it's got to have 8. So then you go, oh, I remember that there's some of these elements that can form more than one pair between it and another atom. Is Si one of those?
Yes.
Okay, that would be column 14, group 14. H isn't one of them, right? Is Se one of them?
Yep.
Yeah, here's Se. It's in column 16. It can form a double bond. And so can this one. So what we're going to do, okay, is we're going to take away one of these unshared pairs on the outside, say here. Take them away. And where do you think they'll have to go?
In between SE and SI.
In between. Okay? So they go in between. Does that make sense? Now, what you can do is you can go, hey, I want to look at my original structure and see if my unshared pairs are the same. So I look at Se. How many unshared pairs did it have before? Unshared means that they're paired up already. 2. How many do I have here? 2. How many shared pairs were they going to have? 2. I got 2 there. Okay, silicon, how many shared pairs is this going to have? 4. 1, 2, 3, 4. Okay, so then what I do is I'll do this on another page, but then you just go ahead and draw your line structure, and it would be your Si, and it would be double bond Se, bond H, bond H. And your line should match up too with your chart. If you want to look at your chart, it should match up. Just as a way to kind of show that. So, on the board here, I have the ones I'd like you to practice for tomorrow. And then realize there's triple bonds that can form. I just showed you a double bond. I need you guys just to practice these and use the rules and step through those rules as we go. Okay? Sometimes students get confused. Unless I have a capital I, it's an L. Alright, it's Cl. So sometimes students will go carbon and iodine. Don't do that, please. Unless it's a capital I with it dash across the top and bottom. Because then you're going to get yourself, it's not going to work out.